Hello guys, welcome back to Calculus. This is going to be class 9, approximating the area under the curve still. But we're going to be including a couple of new things here. We're going to be including doing approximations at midpoints, finding approximations when the curve is under the x-axis, or when we have negative areas, and then also approximating from tables, so given a table of values. So let's start with first a midpoint Riemann-Sum approximation and what that means. First, let's consider the curve y equals x squared, so your basic standard quadratic function. Okay, we're going to approximate the area under the curve from x equals 0 to x equals to 8. So we have our basic curve here, y equals to x squared, right? We have our function here. And again, we're going from x equals 0 to x equals 8. So we're starting from here and we're going up to 8. Notice in our question, it says to use 4 equally spaced subintervals. So again, Riemann sums are rectangles. So knowing that we have 4 equally spaced subintervals, that's going to be able to tell us the height of each of those rectangles. Remember, we were saying that the height here, okay, is going to be defined so that it is horizontal, right? From 0 to 2. We got from 2 to 4, 2 to 6, and then 6 to 8. That will provide us 4 subintervals for those rectangles. I know last week we discussed the heights, right, as b minus a over n, right, where b was the higher endpoint of our interval, a was the lower endpoint of our interval, and n was how many rectangles. But I want to introduce a little bit of a new notation here and talk about the fact that the height, remember, the height is just the change in your x. So we might want to change that notation instead of h to delta x. Delta x. Delta x is going to be, again, b minus a over n. And in this case, your b is 8, your a is 0, and your n, or how many rectangles we're looking for, is 4. Therefore, 8 divided by 4 is 2. And that makes sense. If you notice, the width of each of these intervals is 2. Okay, so those are the heights of each of your 4 rectangles. If we're doing the first problem here, and we're looking for a left-hand approximation, notice for each of those intervals, we're going to use the x-coordinate from the left-hand side. So if I'm looking for the area under that curve and we want to use a left-hand approximation, notice your first left-hand rectangle, right, is going to use the value of the function from the left, or 0. So here I have delta x times f of 0, or 2 times 0. We want to add on the value for our second rectangle. So notice here that rectangle using the left endpoint approximation, we have another delta x times f of 2. So this is going to be 2 times 2 squared, okay, which is 4, and we'll fill that in just a second. And we go to our next interval. Okay, notice here again from 4 to 6, the left endpoint is 4, so we're using that rectangle there. So again, another delta x, that's your height, okay, or your f, and your times your f of 4, so that's plus 2 times 4 squared. All right, and then again one more time here, but now using the left endpoint of the last but not least rectangle here. Again, we're going to have plus delta x times f of 6 using the left endpoint. So that's 2 times 6 squared. So we're just going to evaluate each of these. We have 0 plus 8 plus 32 plus 72. And then we can add those two together. So that's going to be 112 square units. If we want to do the same thing, but instead of using a left-hand approximation, use a right-hand approximation, the only thing that's going to change is now we're going to use the endpoints of each of the intervals that are on the right-hand side. So I'm going to take away these left-hand approximation rectangles, okay? And let's look a little closer here in terms of using the right-hand approximation. For your first interval, notice there, okay, on the right, we have our value at 2. So again, this is another, your height times f of 2, or the base of what would be your rectangle there. In addition, we're going to do it the same thing on the next interval. We have delta x, that is our height, that's still 2. And now the base of the rectangle is going to be f of 4. So plus another delta x and f of 4. Going to continue through again, another height and f of 6, and plus another delta x, f of 8, continuing through with those rectangles. Notice here, just reinforcing this idea that our rectangles here, okay, are an over approximation. Remember here, our function is increasing, which means that the right-hand side is going to be above the left-hand side, which makes sense that this right-hand approximation is going to be an over approximation. We can see that because our rectangles are over our curve. So again, 2 times 2 squared plus 2 times 4 squared plus 2 times 6 squared, and then plus 2 times 8 squared. Just evaluating those there, we have 8 plus 32 plus 72, and then we have 64 times 2, and that's 128. So if I combine those together, that would give us 240 square units. Notice that the pink rectangles were an over approximation, and before, when we had the blue rectangles or the left-hand approximation, that was an under approximation. Last week in class, however, we started discussing what would be a better approximation. And some of us talked about, well, if we added more rectangles, we would get better, and other ones were talking about the fact, well, if I take this information and rather than using the left hand or the right hand for each of these intervals, what if we use the midpoint? What if we use the midpoint for each of those intervals? So now what's happening here is, in order to approximate the area for each interval, instead of using the left endpoint or the right endpoint, we're going to use the value of the function right smack in the middle. So again, it's still a rectangle, so we still have our height times our base, or the value of the function, but in this time the value of our function is f of 1, because 1 is the midpoint between 0 and 2. If we go to the next interval, the next subinterval, the midpoint between 2 and 4, that's going to be 3. So again, if I'm looking at my rectangle here, part of it is above my curve, part of it is below my curve. So the next area would again be delta x times f of 3. Continuing on to the next one. Again, your height here is going to come from the midpoint. The midpoint of 4 and 6 will be 5. So again, combining those two, we have delta x times f of 5. And last but not least, our last rectangle here, which has again a midpoint between 6 and 8, which is 7. That's going to be delta x times f of 7. So we have 2 times 1 squared plus 2 times 3 squared plus 2 times 5 squared and plus 2 times 7 squared. Just approximating and combining, we have 2 plus 18 plus 50, and we're going to add to that 49 times 2, and that is 98. So combining all the way through, okay, this approximation here will be 20, 80, 178 square units. Notice that this value here, the 178, is in between the 112 and the 240, which would make sense, because if this is a better approximation, it should be over the under approximation, but less than the over approximation. Still, right now, we don't know the exact value, but don't worry, that will be coming very soon.